myself, Henasha, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss a most important topic of system of linear equations and matrices. So the topic is Cayley-Hamilton theorem. So let us start with its statement. Every square matrix satisfies its own characteristic equation, right? So the matrix should be compulsory a square matrix of order n cross n. Then only it will satisfy its own characteristic equation. So in this, firstly we have to find the characteristic equation, which is given by determinant of a minus lambda I equals to 0. Right? This is the general form. Now suppose we want to use the shortcut technique, which is of order 2 cross 2, right? So the equation is given by lambda square minus s1 lambda plus s2 equals to 0, where our s1 is equals to what? Trace of A. That means the sum of principal diagonal elements of the matrix A. And our s2 is equals to what? Determinant of A. Right? Then we have the shortcut technique for a matrix of order 3 cross 3. So the characteristic equation is given by lambda cube minus s1 lambda square plus s2 lambda minus s3 equals to 0. Again our s1 is equals to what? Trace of A. s2 is equals to sum of minors of principal diagonal elements, right? And our S3 is equals to, lastly, determinant of A. Using these two equations, what we will do? Firstly, we will find the characteristic equation. Then, in order to verify the Cayley-Hamilton theorem, we will replace lambda by our matrix A and check whether we will get answer as a 0 matrix or not. Okay, so now let us solve one example based on this. We have to verify the Cayley-Hamilton theorem for the following matrix A, and we have to find A inverse and A raised to 4. Right? So let us start with the solution. So here we are given A as 2 minus 1 1, minus 1 2 minus 1, 1 minus 1 2. Okay, so now the characteristic equation will be given by determinant of A minus lambda I equals to 0. So firstly we need to find A minus lambda I. That is, we have to subtract lambda I from our matrix A. So minus lambda times I will be equals to minus lambda times 1 0 0 0 1 0 0 0 1. Right? On subtracting, there will be change only in the principal diagonal elements. So the changes are 2 minus lambda, 2 minus lambda, 2 minus lambda. Other all elements will remain same because we have zeros everywhere else. Okay? Now, let us find the characteristic equation using our shortcut technique for a matrix of order 3 cross 3, which is given by lambda cube minus s1 lambda square plus s2 lambda minus s3 equals to 0. Okay. Now let us find the value of s1, which is equals to the sum of principal diagonal elements of a matrix A. So our matrix A is equals to 2 minus 1 1, minus 1 2 minus 1, 1 minus 1 2. Okay, now let us find the sum of the principal diagonal elements. So it will be equals to 2 plus 2 plus 2. So answer is equals to what? 6, right? Now S2 is equals to sum of the minors of principal diagonal elements of the matrix A. So here the principal diagonal elements are 2, 2 and 2. So firstly let us find the minor of these two. So hide this row and column. So the minor will be equals to what? 2 minus 1 minus 1 2. Similarly, let us find the minor of these two. So hide that row and column, right? So the minor will be equals to what? 2 1 1 2. And lastly find the minor of these two. Hide the corresponding row and column. So the minor will be 2, minus 1, minus 1, 2. Now we have to simplify all these three determinants, right? So answer will be 4 minus 1 plus again you will get 4 minus 1 and last also the answer will be 4 minus 1. Now on simplifying you will get 3 plus 3 plus 3, right? So answer will be equal to 9. So this is the answer of our S2. Okay, now let us find the value of S3. So S3 is equals to determinant of A, right? So let us find the determinant of the matrix A. So keep 2 as it is. Now you will get 4 minus 1, right? Plus 1 keep as it is. Now you will get minus 2 plus 1. And again keep plus 1 as it is. So you will get 1 minus 2. Okay. Now simplify this. So you will get the answer of the determinant as 4. So the value of S3 is 4. Okay. So now let us substitute the value of S1, S2 and S3 in our characteristic equation, which is given by lambda cube minus S1 lambda square plus S2 lambda minus S3 equals to 0. So now let us put the value of S1, which is 6, S2 is 9 and S3 is 4. Okay. So finally you will get your characteristic equation as lambda cube minus 6 lambda square plus 9 lambda minus 4 equals to 0. Okay. So now in order to verify the Cayley-Hamilton theorem, we need to show that whenever we replace lambda by a, right, that is a cube minus 6a square plus 9a minus 4i should be equals to 0. Okay. So now we'll name this equation as our equation 1. Okay. Now let us first find the value of a square. So a square is equals to what? A into a. So write the matrix A 2 times. Now let us multiply these two matrices, right? So consider the first row of this matrix and first column of this matrix. So now what you will get? 2 into 2, 4. Now minus 1 into minus 1, so plus 1 and lastly 1 into 1, so answer will be again 1. Add these 3, so you will get your answer as 6. Okay. Now consider the first row and second column, right? So now the answer will be equals to what? Minus 2, then again minus 2 and lastly you will get what? Minus 1. So adding these 3, what you will get answer as minus 5. Now look at our matrix A. This is a symmetric matrix, right? Which have number as 2 and 1. So what A square will have 6 and 5. Just put the sign accordingly, right? Here it is minus, so you have to put minus. Here also it is minus, so you have to write minus 5. And lastly here you have minus, so you have to write minus 5. And in the diagonal we have 6, right? So this will be the answer of A square. Now let us find the answer of A cube, which will be equals to what? A square into A, right? Put the value of A square, which is given by this, and write the value of A. Okay. Now we have to multiply these two matrices. So again consider first row from this matrix and first column from this matrix. Okay. So what you will get? 12. Then here you will get plus 5 and plus 5. So you will get your answer as what? 22. Okay. Again consider the first row of this matrix and second column of this matrix, right? So what you will get? Minus 6, minus 10, right? And lastly you will get minus 5. So answer will be what? Minus 21, right? So answer is 22 and minus 21. Now according to the symmetricity of matrix A, what you have to put? 22 in principal diagonal elements, right? And you have to write your matrix of A cube. Right? Now we will put the values of A square and A cube in our LHS, which is given by A cube minus 6A square plus 9A minus 4i. Now firstly we have to multiply the matrix of A square by 6. So you will get this matrix. Multiply our given matrix A by 9. So you will get this matrix. And lastly, multiply our identity matrix of order 3 cross 3, which is given by 1 0 0 0 1 0 and 0 0 1. So on multiplying, what you will get 4 0 0 0 4 0 and 0 0 4. Now simplify these three matrices by adding it. So we will get 22 minus 36 plus 18 minus 4. So answer will be 0. Similarly, simplify all the terms of the matrices. So you will get answer as a 0 matrix, right? So finally, what we have derived, the matrix A satisfies its own characteristic equation. Hence, our Cayley-Hamilton theorem is verified. Okay. Now we have to find the value of A inverse. So on multiplying, you will get A inverse times. Write your equation 1, that is A cube minus 6A square plus 9A minus 4I equals to 0. Okay. So now multiply, so you will get finally A square minus 6A plus 9I minus 4A inverse equals to 0. Okay. Now you have to make subject as 4A inverse. So 4A inverse will be equals to what? A square minus 6A plus 9I. Right? Now you have to put the value of A square, A and I. And also multiply A by 6 and your identity matrix by what? 9. Now we simplify these three matrices, right? So your answer will be 6 minus 12 plus 9, right? So answer will be what? 3. Similarly, simplify all the elements of all the three matrices. So your answer of A inverse will be equals to 1 upon 4 times 3 1 minus 1 1 3 1 minus 1 1 3. Okay. Now we have to find the value of what? A raised to 4, right? So we will multiply our given equation by A. So on multiplying, you will get A times A cube minus 6A square plus 9A minus 4I is equals to 0. Why we have multiplied our equation 1 by A only? Because we want to find A raised to 4, right? So A into A cube will be A raised to 4. So we have multiplied our equation 1 by A. So now multiplying, we will get A raised to 4 minus 6A cube plus 9A square minus 4A is equals to 0. Now make subject as A raised to 4. So you will get A raised to 4 is equals to, take this on this side, 6A cube minus 9A square plus 4A. Now let us substitute the values of A cube, A square and A, right? And simplify. So what you will get? 132 minus 54 plus 8. So you will get your answer as 86. Similarly, minus 26 plus 45 minus 4. So you will get your answer as minus 85. Similarly, simplify all the terms of these three matrices and you will get your answer of A raised to 4. Okay. So in today's session, we have studied a very important topic, that is Cayley-Hamilton theorem. So what is the statement? Every square matrix satisfies its own characteristic equation. So whenever we have to verify Cayley-Hamilton theorem, what we have to do? Firstly, we will find the characteristic equation, right? Now in all we have three types of formula. The general form is determinant of A minus lambda I equals to 0. Or you can use our shortcut techniques. So the characteristic equation of the matrix of order 2 cross 2 is given by lambda square minus S1 lambda plus S2 equals to 0, right? Where S1 is trace of A and S2 is determinant of A. And similarly, the characteristic equation of matrix of order 3 cross 3 is given by lambda cube minus S1 lambda square plus S2 lambda minus S3 equals to 0. Again our x1 is trace of A, s2 is sum of the minors of principal diagonal elements, and s3 is determinant of A. Now after finding the characteristic equation, the next step is we have to replace lambda by A, right? Matrix A. So on replacing, you have to verify whether you are getting answer as a 0 matrix or not. Okay, and suppose you have to find A inverse or A raised to 4, what you have to do? Multiply this characteristics equation by A inverse or A etc. Right? So I hope you have understood throughout the session. Thank you for watching.